Hello there. Welcome to the Sleep Lab. 40 light years away, 7 worlds orbit a star smaller than Jupiter. Tonight, we will investigate whether any of them could be breathing. This star was invisible to us until 1999, not because it was far, because it was too faint to notice. Trappist 1 is an ultra-cool red dwarf, spectral class M8. Science almost missed it entirely. Its surface burns at only 2,550 Kelvin. Our Sun runs at 5778. From any orbiting planet, this star appears as a dull cherry red disk. Not blazing white, a slow, smoldering coal in the sky. The star is roughly Jupiter's size, but it is 84 times more massive. That density is extraordinary. Squeeze that much mass into that small a volume, and you get something almost too strange to visualize. Here is something that should unsettle you. This star may be up to 9.8 billion years old. Life on Earth needed 4 billion years to reach complexity. So what has had time to develop here? We will return to this question in the final minutes. The star was not named by astronomers initially. Belgian scientists built a small telescope in Chile. They named it Trappist, after their favorite style of beer. The star, and eventually 7 planets, inherited that name. Michael Gillen discovered the first planet from his couch. He was reading transit data on his iPhone. That is how a world 40 light years away was found on a personal device, in a living room. Science does not always look like science. In 2016, astronomers counted 3 planets. Then NASA's Spitzer Space Telescope looked harder. The final tally reached 7. 7 rocky worlds around a single dim star. That was a record no system had broken before. The entire system fits inside a space 3 times the width of Jupiter's moon system. Every orbit is tighter than Mercury's path around our Sun. These planets are packed with forensic precision. Nothing about this architecture feels accidental. Stop for a moment. 7 rocky planets, all within a space smaller than Mercury's orbit, all around a star the size of Jupiter. Ask yourself honestly, does any part of your intuition say this system should not exist? We know the system is edge-on from Earth. That alignment is statistically rare. It means every planet passes directly across the star's face from our viewpoint. Without that luck, none of this would have been detectable. Alignment is everything in detection science. The planets are not gas giants. Precise mass measurements confirm they are rocky. Some carry up to 5% of their total mass in water. On Earth, that figure is 0.02%. The difference is staggering. Some of these worlds may be true water planets, not oceans sitting on rock. Water composes a significant fraction of the entire planet body. No landmass, no continental shelf, just depth, pressure, and liquid extending inward for hundreds of kilometers. The planets are tidally locked. One face permanently toward the star, one face permanently away. The day side bakes under constant red light. The night side sits in absolute, unbroken darkness. No sunrises, no sunsets, ever. Here is the deeper problem. Tidal locking creates extreme temperature gradients between hemispheres. Winds of catastrophic speed could result. Could any atmosphere survive that internal war? This question has no confirmed answer yet. We will close this loop in the final minutes. Stand on Trappist 1D. Look up. You would see neighboring planets hanging visibly in the sky. Some appear larger than our moon looks to us. These are not distant dots. They are worlds you could watch, with your naked eye, in real time. The 7 planets maintain a gravitational resonance chain. For every 2 orbits of the outermost planet, inner ones complete 3, 4, and 5. This is orbital commensurability, a locked numerical rhythm, held stable across billions of years. 3 planets sit inside the habitable zone. Planets E, F, and G receive enough stellar energy for liquid water to theoretically exist. Of these 3, Planet E is the closest match to Earth's size and energy intake. It is the prime suspect. Planet E receives a similar energy flux to Earth. Its density suggests a rocky interior. It sits at the inner edge of the habitable zone. Scientists have given it a formal habitability index score. No other exoplanet scores comparably on all 3 metrics simultaneously. Consider this carefully. We have spent decades searching for Earth-like planets. We found a candidate 40 light-years away, around a star named after beer, discovered on a couch. Does the universe have a sense of irony? Or are we just terrible at predicting where to look? The Hubble Space Telescope ruled out thick hydrogen atmospheres on several planets. This is significant. Hydrogen-dominated atmospheres, like Neptune, are hostile to biology as we understand it. Thinner, denser atmospheres suggest conditions closer to terrestrial. That narrows the search considerably. The outermost planet, Trappist 1H, completes a full orbit in just 19 days. Yet it receives so little stellar energy that it is likely frozen solid. Proximity to a star does not guarantee warmth. Luminosity determines temperature, not distance alone. Red dwarf stars produce violent stellar flares. The radiation hitting these planets can be 1,000 to 100,000 times stronger than what Earth receives from our Sun. That is not a minor detail. That is a potential atmosphere stripping, biology terminating bombardment on a continuous schedule. Here is the counterargument. Trappist 1 is ancient, up to 9.8 billion years old. Stellar flare activity typically decreases as a star ages. If the worst radiation occurred early, surviving planets may now sit in a relatively calmer environment. Time may be the shield. This star has a total lifespan of 12 trillion years. Our Sun will last roughly 10 billion. Trappist 1 will outlive our Sun by a factor of over 1,000. So the real question is this: what kind of life could evolve given that much time? We return to this in the final minutes. This star sits inside the constellation Aquarius. Before discovery, it carried a cold catalog number, nothing more than coordinates disguised as a name. Now it holds 7 worlds and a beer legacy. Science has a habit of hiding its most significant findings in plain sight. 40 light-years is the distance. On a galactic scale, that is negligible. The Milky Way spans 100,000 light-years. Trappist, one is practically adjacent. Yet even at the speed of light, reaching it takes 40 years. Proximity is relative to the scale you are measuring. The video game Elite Dangerous updated its star map to include Trappist, one with accurate scientific data. Players can fly to the system and observe the planets in real-time simulation. A discovery so significant it crossed from research journals into interactive entertainment. That boundary crossing is rare. The James Webb Space Telescope has made Trappist, one a priority target. Webb can analyze starlight filtered through planetary atmospheres. It searches for water vapor, methane, carbon dioxide, and oxygen. Each detected molecule is a data point in the most important investigation currently running. Pause here. Webb is scanning alien atmospheres for the same gases that indicate life on Earth. But what if life on those planets uses entirely different chemistry? Are we searching for ourselves instead of searching for life? That distinction may determine whether we ever find anything. The planet's nicknames come from specific Trappist beers: Rochefort, Orval, and Westfalteren, Belgian monastic breweries. The astronomers who found these worlds named them after something they loved. There is something methodically human about that. Science and ritual are rarely as separate as we assume. The atmospheres of these planets are 80 times easier to study than those around sun-like stars. Trappist-1's small size and low luminosity create ideal transit conditions. When a planet crosses the star's face, more atmospheric signals reach our instruments. Small star, outsized scientific opportunity. The resonance chain holding these 7 planets in rhythm has persisted for billions of years. Orbital commensurability of this complexity does not emerge randomly. It requires specific formation conditions, gravitational sculpting over deep time. This system was not just born, it was shaped. Planet E remains the most Earth-comparable world ever documented. Size match, density match, and energy flux match. 3 independent metrics pointing toward the same conclusion. In forensic terms, that is not coincidence. That is convergent evidence. And convergent evidence demands serious investigation. 9.8 billion years is not just a number. Earth produced complex life in 4 billion. These planets have had nearly twice that window. If biology found even a single foothold here, evolution has had extraordinary time to build something unrecognizable. Tidal locking seemed like a verdict. Permanent day, permanent night, and catastrophic winds. But recent climate modeling changes that reading. Sufficient atmospheric pressure can drive heat circulation across the terminator zone. That boundary between light and dark may actually be the most stable, temperate region on the entire planet. 12 trillion years of stellar lifespan raises a quieter problem. Trappist-1 emits almost no ultraviolet radiation. Early Earth needed UV to drive the chemical reactions that sparked biology. Life here, if it exists, would run on entirely different photochemical pathways. Not impossible, just built from a completely different instruction set. The radiation bombardment concern has a partial answer. Magnetic fields can deflect stellar wind. Earth's magnetosphere protects surface biology continuously. If Trappist 1e maintains an active planetary dynamo, a magnetic field is possible. Dynamo activity depends on interior heat. Rocky, dense planets retain interior heat longer. The forensic chain holds. Trappist 1 is ancient, stable, and surrounded by rocky worlds in a habitable zone. Its atmospheres are measurable. Its planets are Earth-scaled. Its star will burn for 12 trillion years. If biology is a repeatable process in the universe, this system is where the next confirmed example may be found. If this investigation shifted how you see that faint red point in Aquarius, subscribe before you sleep tonight. Every episode goes deeper. The Sleep Lab signs off, but Trappist 1 never stops turning.